Here you have to find out the nature of roots of this quadratic equation. NCRT exercise 4.4 question number 1 A part. You have to find the nature of the root, and if the roots are real, then you have to find the roots first. So we know that the standard quadratic equation is ax square plus bx plus c is equal to 0. So if you compare this, you get a is equal to 2, b is equal to minus 3, and c is equal to 5. A is 2, b is minus 3, c is 5. So to find the nature of the roots, we require discriminant capital D is equal to b square minus 4ac. So that equals to minus 3 square minus 4, a is 2, and c is 5. We get here 3 square is 9, minus 5 to the 10, 10 4 is 40. That is nothing but minus 31. Okay. Since the roots are since the roots are discriminant is negative, discriminant is less than 0, negative means it will be less than 0. Therefore roots are imaginary. Roots are imaginary. Or simply not possible. The roots are imaginary or simply not possible. Okay. So here the roots are not possible. So you don't have to find out the roots. In some other question where the roots are possible, if the discriminant comes to be positive, you see this second part here. The question is 3x square minus 4 root 3x plus 4 is equal to 0. Let's find the discriminant here. The standard equation is quadratic equation is ax square plus bx plus c is equal to 0. If we compare this, a is equal to 3, b is equal to minus 4 root 3, and c is equal to 4. A is 3, B is minus 4 root 3, and C is 4. So here the discriminant D will be equal to B square minus 4 root 3 whole square minus 4AC minus 4 into 3 into 4. 4 square is 16, 3 is a 48. 4 4 is 16, 3 is a 48, minus 48. The discriminant equal to 0. This means the roots are there, possible, and they're equal also. So here you see the possible roots which you have to find out is the roots are real and possible. You need to find them out. Okay. So in order to find the roots, now you see, in order to find the roots, what you will do here, so you need to find the roots here. Now in order to find the roots here, what you will do, let's see, the x1, the first root x1 is equal to minus b plus under root d upon 2a. So this will give you first root. Minus b you find out from this, minus 4 root 3. So minus minus will become plus 4 root 3 plus d is 0, so that will be 0 upon 2 into a value is 3. You can cancel here. 2 ones are 2, 2 twos are 4. That is equal to 2 root 3 upon 3. And the second root, that is x2, you have to find out. x2, that is second root, minus b minus root d upon 2a, that is again same thing. Minus minus will be plus 4 root 3 upon 2 into 3. Cancel out 2 to the 4, that is 2 root 3 upon 3. Right? So this way you can solve this type of questions where you have to tell the nature of the roots utilizing these quadratic equations. Second part says find the values of k. Question number 2, find the values of k for each of the following quadratic equations so that they have two equal roots. So that they have two equal roots. The question is, what does the question want to say is, you read the question carefully, find the values of k. It wants the values of k in the question. So the equation is second part 1 NCRT, 2x square plus kx plus 3 is equal to 0. This is the equation. Okay. The 2x square plus kx plus 3 is equal to 0. Now here you see, in this question, you have to find the value of the k so that the nature of the roots, so that the discriminant that here you see, both the roots are equal. Just give another question. And for the roots to be equal, you know the condition is the discriminant equals to 0. D is equal to 0. You know, standard equation is ax square plus bx plus c is equal to 0. So if you compare this, you will get a is equal to 2, b is equal to k, and c is equal to 3. Right? A is 2, b is k, c is 3. Now next you see, as we know very well that for the roots to be equal, the condition is the discriminant should be equal to 0. D should be equal to 0. Right? And for the value of d, you see here, the value of d is equal to what? B square minus 4s should be equal to 0. Now here you see b value is equal to k. So that will give you k square minus 4. The value of a is 2 and the value of c is 3. That should be equal to 0. This gives you k square is equal to 4 to the 8, 8 3 is 24. 24 here. K is equal to square root of 24. That can be written as 4 6 is 24. The square root of 4 is nothing but 2. That is 2 root 6. So k is equal to 2 root 6. Right? And this was k square. So here you will write here plus minus. It could be positive also. It could be negative also. So the value of k is plus minus 2 root 6. Right? Question number 3 says, is it possible to design a rectangular mango groove whose length is twice its breadth and area is 800 meters square? If so, find its length and breadth. As from the question, it already says that is it possible to design a rectangular mango groove whose length is twice the breadth? So, according to the question, question number 3, the length of the mango groove is equal to twice the breadth. So write down, let the length so first of all here is the breadth. So you will take breadth, not length. So let the breadth of mango groove is equal to x. Therefore its length is 2x. So length is 2s, breadth is x. Therefore its area is, because in question it talks about area, so you have to calculate area. Length into breadth, that is x into 2x. And that equals to how much? Good morning. 800 meters square. So you'll get x square is equal to 400 meters square. So x is equal to 20 meters, because the side of any mango groove cannot be negative. So x is equal to 20 meters. We'll take positive value. So x equals to 20 meters. Therefore length is equal to 40 meters, twice x it was, and breadth is equal to x, that is 20 meters. The length and breadth of the mango grooves are, therefore the length and breadth of mango grooves are 40 meters and 20 meters. Okay, the length and breadth of the mango grooves are 40 meters and 20 meters. One more question is there, and this question, is it possible to design a, is the following situation possible? If so, determine the present ages. Two more questions are there, 4 and 5. We will do on the next turn. Okay.